Hi everyone. So today I will be discussing the June 2021 P2 paper. Okay. So let's move on to the first question. Okay. So Adina is saving money to buy a new computer. She saves £5 in week 1, 5.25 in week 2, okay, and 5.5 in week 3, and so on until she has enough money in total to buy the computer. She decides to model her savings using either an arithmetic or geometric series. Using the information given, state with the reason whether an arithmetic series or geometric series should be used. So obviously what we need to check here is in an arithmetic series, we know we have a common difference, while in a geometric series, we have a common ratio. So you just need to give a reason. So what do we have here? So you have 5 in week 1, 5.25 in week 2, and 5.50 in week 3. So if you check your three terms, term 1, term 2, and term 3, I think we can very clearly see that we have a common difference here, isn't it? Term 2 minus term 1, you get a 0.25 difference, and term 3 minus term 2, you get again a 0.25 difference. So there is a common difference. There is no common ratio. So if you go to divide, the division you will see 5.25 divided by 5 and 5.50 divided by 5.25. The answers are different. So we have a common ratio. I mean, we have a common difference here. So you can write there is a common difference. There is a common difference. Therefore, it is an arithmetic progression. Okay, so let's move on to Roman number 2. Write down an expression in terms of n for the amount of pounds saved in week n. So they want you to find the amount you save in week n. So the amount you save in week 1 is 5. The amount you save in week 2 is 5.25. The amount you save in week 3 is 5.50. So they want you to find the amount you save in week n. So which means they want you to find the nth term, the Tn or the Un, the nth term. So nth term is a plus n minus 1d. So a, the first term is 5 plus n minus 1 into common difference is 0.25. So it's a matter of simplifying this, or you can just leave it, write down an expression in terms of n for the amount saved. Something like this, this should be enough. Okay, so let's move on to part B. Given that the computer Arena wants to buy costs £350, find the number of weeks it will take for Adina to save enough money to buy the computer. So the computer she wants to buy, so she's saving money. So at the end of the day, what we do is every week she saves the money, and at the end she's gonna add up the money, and the amount when you add up, it should be enough. It should be like, it should cover the 350. So what we need to do here is obviously. It's not the term equation at this point. In this part B, we need to get the sum equation. So sum equation, adding everything, Sn. So they're asking the number of weeks. So your sum needs to be 350. Or in other words, you could say greater than or equal 350, right? Because it's highly unlikely that you would get this sequence. It might add directly to 350, or you might most of the time exceed. So we need to find the place where it first exceeds. Okay, so anyway, I'll just do it equal to 350 at this point. So we may get a decimal. So if we get a decimal, we'll just have to round it up. That's all. So sum equation is n over 2, 2a plus n minus 1d equals to 350. So n is unknown. 2 times a, first term is 5 plus n minus 1 into common difference is 0.25 equals 350. Okay, so then we end up getting here, what do we get? N over 2, you get here 10.25 n minus 0.25 equals 350. So I think I'll take the 2 to the other side, 350 times 2, that gives me a 700. And here I get 10n plus 0.25 n square minus 0.25 n. So I expanded the bracket with n, and I took this 2 division 2 to the other side as multiplication. Okay, so we just need to simplify this and get the value find. So it's gonna be a quadratic equation, isn't it? So 0.25 means, I think I'll multiply the whole equation by 4. 0.25 is 1 over 4. So if I multiply the whole thing with 4, I should get a nice, I would get a nice equation without any decimals. So this becomes 40n, 0.25 into 4, that's 1. So 10 square minus n, 700 into 4 is 2800. So I get the n square minus n, 2800, minus n. So actually 40n minus n is plus 39n, isn't it? Minus 2800 equals 0. So now it's time for your calculator. So take the cal and we go to mode, equation, and we go to quadratics. So A is 1, B is 39, C is minus 2800, and I end up getting, okay, so I end up getting these decimal figures, right? So we get x is, so we end up with x is 36.89. So let me write one step to show the method. So n equal minus b plus or minus, let's just show the method, minus b square minus 4 into a into c. So I'm just writing a method just to show that I have done something, and we can just put the value here. So the value we got was, so this is the quadratic formula, I just wrote it down so that we have a method that we use to solve the quadratic. So the answer you get in the calculator is accurate. So 36.89. So that's one answer, n equal 36.89. So that will probably maybe come with the positive part. And the other answer for n, was minus 75.89. Minus 75.89. So now, what do we need to do from here? So we need to find the number of weeks. N is the number of weeks. So n cannot be negative. So this is not possible. You can eliminate it. Okay, cannot be negative. So you can eliminate that issue, that answer. So n is 36.89. Now you don't have 36.89 weeks, right? So the number of weeks is a discrete value. So you need to get a perfect answer. So this actually means that you don't have a exact place where you immediately where you collect exactly 350. So it's like on the 36th week you are, so this is 36.89 is a figure in between 36 and 37, which means in the 36th week your sum is a little bit below 350, the total of 350, while in the 37th week you will get a total greater than, total exceeding 350 pounds. Okay, so if you want, I'm not going to do that, it's not necessary to do that. The answer here is directly 37 weeks. So writing 37 is more than enough. So if you by any chance check S36 and S37, sum of 36 weeks and sum of 37 weeks, you can just do it. You don't have to do it in the exam. So if you check this answer, n over 2a plus n minus 1d, you will get this answer. Sum of the money for the first 36 weeks will definitely be a value that is lower than 350, while the sum of the money for the first 37 weeks will definitely be an amount exceeding 350 pounds. Okay, so anyway, so our answer is just going to be 37 weeks. Okay. Okay, so moving on to question number 2. Let me make it a little bit larger. Okay. So they say figure 1 shows a sketch of the curve with equation y equals 4 to the power x. So copy of figure 1 labeled diagram 1 is shown on the next page. Okay, so I'm going to draw it over here. Okay, I will not go to the next page because I cannot see the questions. On diagram 1, sketch the curve with equation y equal 2 to the power x. Okay, so on the same diagram, so you would be in the exam, you would be drawing over here. So I'll be drawing over here because I want to look at the questions. Okay, so you just have to draw your answers. On the exam, make sure you draw it on diagram 1. Okay, so I just want to have a look at my questions. So I will be drawing it over here because it's the same figure. On diagram 1, sketch the curve with equation y equal 2 to the power x. So when you're drawing 2 to the power x, so you need to have some kind of an experience here. So these are exponential type of graphs. The place where these graph cuts the y-axis is always at 0, 1, isn't it? It cuts the y-axis at 0, 1. So let me make it a little bit larger. They always cut the x-axis at 0, 1. And also you have the x-axis, the y equals 0 line as an asymptote, isn't it? Y equals 0 line is an asymptote. So these are the two main properties in exponential graphs, 4 to the power x, 2 to the power x, or rather a to the power x type of graphs. Okay. So when you're drawing y equal 2 to the power x, so I think you can definitely see that 2 to the power x is definitely lower. I mean, the values, the y values you would get for when x is positive. So when x is 1, 4 to the power of 1 is 4, while 2 to the power of 1 is 2 to the power of 1 is 2. So you will definitely need to understand that at the positive side, the values of 2 to the power x graph, it's also going to have this kind of shape. The shape is similar, but it should have the values should go below. So I think we can the values go below. When x is 0, we know all exponential graphs will go through 0, 1. It doesn't matter what graph it is, whether it's 10 to the power x or whatever it is. All the exponential graphs with powers of x will definitely go through 0, 1, because when you cut y-axis, x is 0, which means 2 to the power 0 is 1. 4 to the power 0 is 1. All these graphs will commonly go through this point. And I think you can see when x is negative. So when x is negative, 4 to the power minus 1 is 1 over 4. 2 to the power minus 1 is half. So half is bigger than 1 over 4. So on the negative side, the 2 to the power x graph is going to, values are going to be larger compared to the 4 to the power x graph. So when you draw it, so it's going to be something that looks like this, isn't it? On the negative side, this graph is going above. And on the positive side, it's going lower. So something like this. So this is the type of graph you need to draw. So this is y equal 2 to the power x, which you must label. Okay, that's the type. So you must label the graph. Okay. Then the next one, part B, Roman number 2, y equal 4 to the power x minus 6. So how do you draw this type of graph? So you can see in part A, I mean, they have already drawn you the y equal 4 to the power x graph. So 4 to the power x minus 6 means it's simply a translation. So it's a translation. So minus 6, it's clearly outside. I mean, it's fall into the category of y equal fx plus a, isn't it? So your translation is outside of the bracket, which means it affects the y coordinate. So you must do exactly the same thing, which means you will subtract 6 from all your y coordinates, including your y asymptote. So the y coordinates, including the y asymptote, all of them must move 6 units down. So this needs to happen to the 4 to the power x graph. So in this graph, 0, 1. So when you subtract, 6 units. So from 1, if you subtract 6 units, you end up getting 0, minus 5, right? And then the asymptote y equals 0 would simply come down to draw a dotted line to show the asymptote. So the asymptote will become y equal minus 6. Y equal minus 6 is the asymptote. I think they have not. Okay, so anyway, we'll just draw the same graph, 4 to the power x, just translate it down. Something like this. So this is the y equal 4 to the power x minus 6 graph. So label it. Okay. So this is the y equal 4 to the power x minus 6 graph. Okay. So then after that, label clearly the coordinates of any point of intersection with the coordinate axis here. So we are not done with it because they say us to clearly mark the coordinates of any points of intersection with the coordinate axis. So as we can see, the 2 to the power x graph, okay, we marked that. 4 to the power x minus 6, I've marked this point, that's okay, but I have another point to find here. So the place where that graph cuts the x-axis. So y equals 4 to the power x minus 6 graph. So when you cross the x-axis, you know, y should be 0. So when y is 0, 4 to the power x minus 6, so x equals 4 to the power 6. So now it's a matter of log to index, isn't it? So when you turn log to index here, let me write it in the proper way. So we get here a to the power of c, a to the power of b equals c. So this is logarithm base a, c equal b. Right? So this is the conversion. So this is log base 4, 6 equals x. Okay, so that's the place where you cut the x-axis. So mark it clearly on your diagram. Log base 4, 6. So this is the place where you cut the x-axis. Do they want the values or the coordinates? Label the coordinates. So log base 4, 6, comma 0. So this is the coordinate where you cut the x-axis. Okay. So and the y-axis. So all the cutting points are clearly labeled. Okay. So then let's move on to part B. The curve with the equation y equal 2 to the power x meets the curve with the equation y equal 4 to the power x minus 6 at the point P. Using algebra, find the exact coordinates of point P. So I think we can see point P on our diagram, right? So 2 to the power x and y equal 4 to the power x minus 6, they meet at the point P, which we can quite clearly see here. So we don't need to label it. They have not asked us to label. We're just supposed to find where it meets. So obviously, how do you find the place where two curves meet? So when two curves meet, the method we use is we solve the two equations simultaneously, isn't it? So you need to solve the two equations simultaneously to find the place where the two curves meet. So y equal 2 to the power x meets y equal 4 to the power x minus 6. So let's equate them. 2 to the power x equal 4 to the power x minus 6. So, so I can see here the bases. I mean, x, there's a power here. I mean, the base 2. I mean, there's x with the base 2, power of x. Here also you have power x with the base 4. So to do this sum, I really want my bases to be the same. So it's easy if our bases are the same. So here I have a 2. Here I have a 4. So what we can do is we can replace the 4, the base 4 as 2 to the power 2 and x. So don't forget the power x. So this is 4. Basically, 2 to the power 2 is 4 to 4, and you have the power x here. So this is 4 to the power x. Okay. So I end up getting here 2 to the power x equal 2 to the power 2x minus 6, taking everything to one side. 2 to the power 2x minus 2 to the power x minus 6. So actually, if you look at this, this is a quadratic equation, isn't it? It's a quadratic equation. If I say let, don't take x because x is used, use some other letter, let a be 2 to the power x. You can use any letter you want. Let a equal 2 to the power x, which means 2 to the power of 2x must be a square, isn't it? So when you square both sides, a square, here 2 to the power the x multiplies it to 2 to the power 2x is a square. So you can simply see there's a simple quadratic equation here, 0 equal a square minus a minus 6 replaced. Can you see? I've replaced it. So take in the cal, you can type ABC, or it's pretty obvious the factors here, isn't it? So I think it's quite easy to see here. You can use the cal. It's a minus 3, a plus 2, isn't it? A minus 3, a plus 2. So making each bracket equal to 0, a minus 3 equals 0, or a plus 2 equals 0, we get a equals to 3, or a equals to minus 2. So who is a? A equals 2 to the power x. So replace a back with 2 to the power x, and now it's time to turn log to index. So turn the index form to log form. So once again, a to the power b equals c. I always use the help of this log base a c equal b. So just move the figures. So log base 2, 3 equal x, or log base 2 minus 2 equal x. So I think you should know we can't, the logarithms of negative numbers, they don't exist. Okay, so they don't exist. So this is not an answer. So it's not possible. So your answer is x equals log base 2, 3. What do they want here? By using algebra, find the exact coordinates. So finding the exact coordinates, I need to find the y value as well. So how do I find the y value? So y equal 2 to the power x. I could use y equal 2 to the power x, right? So y equal 2 to the power x. So then what about 2 to the power x? So I think don't go to use x as log base 2, 3 to the power here, because I think you can see 2 to the power x answer. 2 to the power x answer, we can take it from here, isn't it? Here 2 to the power x is equal to 3. So that's equal to 3. So which means here the coordinates of point P are log base 2, 3, 3. So these are the, this is the coordinate of the point P where the two graphs intersect. Okay. Okay, moving on to question number 3. Prove that for all single digit prime numbers p cube plus p is a multiple of 10. Okay, so this is quite simple, just 2 marks. for all single digit prime numbers. So let's think about the single digit prime numbers. So what are the single digit prime numbers? We have the first prime number 2, the next single digit prime number 3, 4 is not there, 5 is a prime number, then 6, no, 7, so 8, no, you can't take 9, and 10. After starting from 10, you have double digits, right? So single digit prime numbers are 2, 3, 5, and 7. So all you got to do is put p equals 3 into these equations. So p cube plus p. So 2 cube plus 2, get the answer. P equals 3. 3 cube plus 3, get the answer. P equals 5. 5 cube plus 5, and p equals 7, which is 7 cube plus 7. So p cube, when p equal to 2 cube is 8, 8 plus 2 is 10, which is a multiple of 10. When p equal 3, there is 3 to the power 3 is 27, plus 3 is 30. 5 to the power 3 is 125, plus 5 is 130, right? So 7 to the power 3 is 343. 343 plus 7, 350, isn't it? Yeah. Yeah, it's 350, right? Yeah, 343 plus, yeah, 350. So what do we need to prove? We need to prove for all the single digit prime numbers, it's a multiple of 10. So very clearly we can see all these, in all these 4 cases, you have multiples of 10, right? So all are multiples of 10, okay? So these are the single digit prime numbers. So write it down as single digit prime numbers are 2, 3, 5, and 7. So all of these are, all values are multiples of 10. Therefore, you can say, therefore, the result is proved. The result has been proved. So you could say something like that, just, just mention something. So all the answers we got are multiples of 10, therefore the result has been proved, okay? Okay, so then moving on to Roman number 2. Show using algebra that for n is an element of natural numbers. I hope you all know this is natural numbers. So natural numbers are what we call as the counting numbers. Counting numbers starting from 1, 2, 3, the integers. So on, natural numbers, counting numbers. Show using algebra that for n is an element of natural numbers. N plus 1 cube minus n cube is not a multiple of 3. Okay, so we need to show it's not a multiple of 3. So let's first get on with the let's open the bracket here and see what we get. N plus 1 cube minus n cube. So I end up, we'll have to expand the bracket here. So n plus 1 cube is n plus 1 into n plus 1 into n plus 1. So you could use binomial expansion here using n 3c0. You could use that, or you could open manually. It's up to you all which way you use. Okay, so I'll open manually. You could use binomial expansion. So n square plus 1n plus 1n is 2n plus 1. And again, open this bracket, n into n square, that's n cube plus 2n square plus n. And then starting with 1 again, plus 1n square plus 1 into 2n is 2n plus 1 into 1 minus n cube. So it's a matter of adding now. So I think you can see n cube cancels off. 2n square plus this 1n square, that gives me 3n square. Plus 1n plus 2n, these two guys will give me plus 3n, and I get plus 1. Is that correct? 3n square plus 3n plus 1. So now what I can do is, you can see now you might be wondering, how can we show it's a multiple of 3? We need to show it's not a multiple of 3. So how do we show it's not a multiple of 3? Like, you can't put values for n here like the earlier case, because you have to show it doesn't work for all the natural numbers, not just for 1, 2, 3, 4. Not just for a few digits. Like in the earlier case, we had to work with only a few digits, just with 4 digits. But but now here we need to work with like infinite number of decimal, whole number. So we need to do it in a general way. So how do we do it in a general way? So I need to show it's not a multiple of 3. So I can see the first two terms, actually they have a multiple of 3, while this guy does not. So what I'll do is I'll take the 3 out, and I end up getting n square plus n, isn't it? N square plus n plus 1. So what does this tell me? So this tells me that that this particular part, this is a multiple of 3, right? So so this is a multiple of 3. So you have a multiple of 3 plus 1. So when you add 1 to a multiple of 3, I think you can immediately understand that it immediately that you can't divide it by 3, because if it's divisible by 3, you have a factor of 3. But if you add 1 or if you add 2, immediately it's not divisible by 3, isn't it? Right, so you have this plus 1 separately adding to the multiple of 3. Okay, so here you can directly write so you add 1 to the multiple of it, or it is 1 more than 1 more than the multiple of 3. So it's 1 more than a multiple of 3. Therefore, it is not divisible by 3. Okay, it's not divisible by 3 for any natural number, for any of those natural numbers. Okay, so that's the so that's the end of that sum. Okay, so moving on to question number 4. Find in ascending powers of x up to and including the term in x cube, the binomial expansion of 2 plus x over 8 to the power 13, fully simplifying each coefficient, right? So we have to get including the term in x cube. So probably that means we'll have to find the first 4 terms, isn't it? Okay, so we'll start the expansion 2 plus x over 8 to the power 13. So when you expand, you start with 13 C0, isn't it? 13 0. So you want to give the x term should be in ascending power, which means you get here 2 to the power 13 times x over 8 to the power 0, right? So next one, 13C1, 2 to the power 12, x over 8 to the power 1. Okay, so you keep on doing this until you get the power of 4, plus 13C2, 12 to the power 11, x over 8 to the power 2, plus 13C3, 12 to the power 10, not 12, I'm sorry, it's 2, right? I'm sorry, I've been writing 12. Should be 2, right? 2 to the power 13, 2 to the power 12, 2 to the power 11, 2 to the power 10, into x over 8 to the power, how much is the power? This is power 3, isn't it? And then finally 13C4, 2 to the power 9, x over 8 to the power of 4. Because I want until the power of, sorry, I don't need power of 4, right? Only until term 3. Okay, so I don't need this guy then. So we can remove this. So I need these 4 terms. So it's time to simplify them. Let's simplify. So 13C0, I think you all know it's directly equal to 1. Any number to the power of 0 is 1. So you end up getting here 2 to the power 13. So 2 to the power of 13 is 2 to the power of 13 equals 8192. Plus the next term 13C1 is 13. 2 to the power of 12 is, so I'll keep it here, we'll multiply it at once, 2 to the power of 12 into x over 8. Okay, so we'll simplify all of them when the time comes. I mean, I'll simplify the next step. 13C2. So 13C2, I mean, we can do it at once, right? No mind, I'll write one step. 13C2, which gives me 13C2, that gives me 78. 78 into 2 to the power 11 into, so the power 2, you know, this power, the square goes inside to both the figures. So you get x square over 8 square. So x square over 8 square, and the final figure 13C3. So you have 13C3, which is 286 into 2 to the power 10 into x cube over 8 cube. Okay, so it's time to simplify this now. 8192 plus, so giving this in the cal, so I have here 13 into 2 to the power 12 into x over 8, so that's 1 over 8. So into 1 over 8, which gives me 6656. And don't forget x. Okay, so the next term, that's going to be 78 into 2 to the power 11 into 1 over 8 square. So 1 over 8 square. That gives me 2496 x square. The final term, so we have here 286 into 2 to the power 10 into 1 over 8 cube. That gives me 572 x cube. Right, so these are the first four terms, and plus it will continue on. So these are the first four terms, the answer for part A. And the next part they're asking you, give your answer to part A to find an approximation for 2.0125 to the power 13, giving you answer to 3dp. So I need to find this expression. So I have the expansion here for 2 plus x over 8 to the power 13. So as you can see, they've got 2.0125 to the power 13. So that immediately should tell us that we need to, just find the value of x. Sorry, we need to find the value of x here, who could make this inside function equal to 2.0125. So that x value we could substitute over here, and we could just get the answer. So let's make the inside equal to part B. Let's make the inside function 2 plus x over 8 equal to 2.0125, because I need to find what is the x value that makes this inside. So this the inside, what is the x value we should use here? So x over 8 equal 2.0125, subtracting 2, that gives me 0.0125. So 0.0125, when I multiply that with 8, I get 1 over 10. X is 0.1. X is 0.1. So that's what you need to substitute here. Substitute x in place of every x, substitute 0.1. So 2 plus 0.1 over 8. 8,192, 6656 into 0.1 plus 2496 into 0.1 square plus 572 into 0.1 cube. So it's a matter of, so this guy, you don't even have to type in the cal, don't do anything. This is definitely gonna be 2.0125. So this is to the power 13 equals, so this other side you need to type it in the cal, and they want the answer to 3dp. So that is 8192 plus 6656 into 0.1 plus 2496 into 0.1 square plus 572 into 0.1 cube. So that gives me 8883.132. Okay, so it's the exact answer. So they want 3dp, so you have to give it to 3dp. 8883.132. So you have to give that exact value there. Okay, so yeah, so you have to give that exact value there. Give your answer to 3dp. So we only got 3dp. Without calculating 2.0125 to the power 13, state with the reason whether the answer to part B is an overestimate or an underestimate. Okay, so they're asking you now you know here. I mean, without using the without calculating this value with your cal, they're asking you whether this is an overestimate or an underestimate. So actually, it's quite easy to say that. I mean, how do we say that it's an underestimate? I mean, an overestimate. Now, we all know here that these terms, that when we do this binomial expansion, to get the true value, to get the exact value, if I want the exact value of this particular, of this guy, okay, if I want the exact value of 2.1025 to the power 13, then I fully need to expand and get all the terms, because this doesn't end from here, isn't it? It does not end from here, because we have 1 to the power 13. So we have so many other terms. We can expand this until x over 8 to the power 13. So you get a lot more terms. So if you add all of those terms, I mean, there are a lot of so many other terms coming until the power x to the power 13. So if you add all of them onto this, only you can get the true value. The true value. So we have removed all. I mean, we have only taken the first four terms. The last terms have not been considered. So many of the last terms have not been considered, which means definitely this is also, since we are adding all these values, this is definitely, it's an underestimate, isn't it? The values, I mean, what we get here is definitely an underestimate of the true value of this. So this is not the true value, it's an underestimate. So you can write in part C. So you can see this is an underestimate. So do they want a reason also? State with a reason. So how do we write the reason? You can say to get the expansion, or you could say to get the exact figure we need to fully expand. Therefore, so what we have is here are the truncated series, right? So this will give us an underestimate. We need to fully expand. You could say this guy. We need to fully expand. Okay, and this is therefore the truncated series will give an underestimate. Okay. So I hope that is clear. Okay, so it's just one mark, but you need to give it with a reason. They ask you for a reason which you must provide, and you must say whether it's an overestimate or underestimate based on your reasoning. So the reasoning here is that to get the exact figure of this guy, we need to fully expand 2 plus x over a to the power 13. Therefore, the truncated series, because we have cut off, the remaining part is all, cut off. So the truncated series will give an underestimate. Okay.